Hey guys, today we're going to talk about recursion and I'm going to show you how to do it in Java, and we're going to have a little refresher on what recursion is, since we covered it already for a little bit in PLD 101, but today I'm going to show you how to do it in Java. As we have talked before, so there is a possibility for you to call other methods from another method. However, when it comes to recursion, what happens is a method calls itself within that same method. So if a method is calling itself, that's what we call a recursive method. So when would we use recursion? We would use recursion for solving any repetitive problems. However, you need to know that recursion is never required to solve a problem. So any problem that is solved with the help of recursion can be solved just iteratively with any loop, any choice of loop that you want. In many cases, as I mentioned before in PLD 101, in many cases your recursive algorithms are not going to be as efficient as iterative algorithms. However, there are a couple of examples where you would want to use recursion over a regular loop. A couple of more things to know about recursion. So whenever recursion occurs, what happens is your program will allocate some memory for your parameters and for any local variables that your method has, and for whatever parameters you're passing to that method too. And it will also store the address of where the control is going to return after that method terminates. So since the method calls itself over and over and over again, at the end of the day, it's going to come down to that first call of that same method that you made. However, your program needs to remember when that first call was made. So it needs to know where that program needs to return back to. So that is called overhead, and that takes place every single time when that method is being called. So every single time you use recursion, you're gonna have overhead. However, that never occurs with a loop. And that is why you will also sometimes may choose to use an iterative loop instead of recursion to solve your problems. However, the recursive algorithms are usually designed faster, and it's easier to solve whatever problem you look at. However, recursion can be executing slower than your loops. So how does recursion work? So for the recursion, we have to have a base case, and base case is just if base case is reached, the method's going to solve whatever problem is at the base case and return. However, if you cannot solve that base case from the first go, the method is going to reduce it to a smaller size of problem, such as a recursive case, a smaller problem, and then it's going to call itself to solve the smaller problem first. For example, when we're calculating factorials, that's a perfect representation of how recursion works if we want to solve the factorials with the recursion. Here you can see the definition of a factorial. Right here, the factorial is a non-negative number and should be a non-negative number. And if n equals 0, there are a couple of rules. If n equals 0, n is our number, then n factorial is going to equal 1. However, if n is greater than 0, then n factorial is going to be 1 multiplied by 2 by 3, and so on, 4, 5, 6, 7, 8, until we reach that number. And here are the same rules in a pseudocode. So if n equals 0, then factorial of n equals 1. If n is greater than 0, then the factorial of n equals 1 multiplied by 2, multiplied by 3, multiplied by 4, and so on, until we reach n. So if your number is greater than 0, then the factorial of that number is going to be the product of all the positive integers that come from 1 up until to that number. And here we have an example of factorial of 6. Right here you can see that it is 1 multiplied by 2, by 3, by 4, by 5, and by 6. And then our base case is going to be where n is equal to 0, because we know that when it equals to 0, then the factorial equals 1. So with the help of the recursion, we're going to try to get to that base case as quick as possible. So the recursive call is going to be your call that's going to work on a reduced version of your problem. So essentially it's just n minus 1. And this is a Java-based solution right here. You can see it for solving the factorial. So we have our method static integer that's going to return an integer called factorial that accepts a parameter of integer n, so the number that you want to calculate a factorial of. And then if that number equals 0, then we're going to return 1. This is our base case. However, if the number doesn't equal 0, we're going to go to else right here, and we're going to return n multiplied by the method call again, but with n minus 1. So this is exactly how the recursion is supposed to work. So you have factorial n minus 1. We're calling that same method. You can see that the names match. Factorial, factorial. We're calling that same method from inside of our method. However, we're calling it with n minus 1 instead of just with n. This is how it's going to work. Here's a little diagram for you. The first call of the method is going to be n equals 4, and it's going to return 24. Second call is going to be n equals 3. We're going to return 6. N equals 2, return value of 2. N equals 1, return value of 1. N equals 0, return value of 1. And then it's just going to go back, as you can see with the arrows. All of these arrows are pointing down, and then after you reach the end, after you reach our base case, n equals 0, we're going back up. So what's going to happen, we're going to multiply 1 by 1 is going to be equal to 1, then multiply 1 by 2 is going to equal 2, then multiply 2 on 3 is going to equal 6, and then multiply all of that number on 4, and it's going to result in 24 being our answer. There are two different types of recursion, direct and indirect recursion. The only difference between them is direct recursion is when a method directly calls itself from within, and indirect is when your method A, for example, is going to call method B, and then method B is going to call method A again. So that is what indirect recursion is. However, you can also add a lot more methods to that indirect recursion. As long as you end up in the same method that you called in the first place, that will be indirect recursion. Another example to use recursion, you can also sum a range of any of your array elements. That could be useful, and let me show you how it works. Here is the code for that. So we're gonna have a public method that's going to return an integer for us. I can tell that by looking at the data type. The return is int. That's why it's going to return integer. And we're passing, it's called range sum, and we're passing an integer array, and then we're passing the starting value and the ending value of our array. Now, we have an if-else structure right here. If the starting value is greater than the ending value, then we're going to return 0. Because that will help us identify when we reach the end of our array. So we're going to pass the index of the starting element of our array, which is 0, and then we are also going to pass the index of the last element of our array, and then we're just going to check once our starting value increases up to the ending value, plus 1, then we're going to know that we reached the end of the array and we don't need to do anything else, and our method can stop executing the recursion. So unless that happens, we have our else, and what's going to happen, we're going to return whatever element is at the position that we're looking at, plus, and here we are calling that method again, as you can see, range sum, we're calling the method from within the method. This is a direct recursion, and we're just passing the same stuff that we passed here. The only difference is that we are increasing our index by 1. So if we were passing 0 at the very beginning, we will be passing 1 into our next iteration of this method. Of course, there's also the Fibonacci series, and if you need a refresher on these, you can go back into the PLD 101 lectures and look at the Fibonacci series explanation that I did. However, this is the code for Java on the Fibonacci numbers and how to calculate them. Here is another example for the greatest common divisor using the recursion. And you can pause to read the code here, but essentially what it does, it just checks for the remainder, because remember that the percent sign checks for the remainder if the number is being divided by whatever number you have as a whole. So if x is divisible by y without any remainder, then we have found our greatest common divisor. However, if not, then we are returning the same number y and the remainder of x divided by y. And again, as you can see here, this is how you can identify easily if the method is recursive. If you see that the method has the same name and calling the same method as a return statement, then probably that method is recursive. It is also possible to write your binary search using recursive methods. However, I would not recommend doing that because it is less effective, less efficient, and you're just going to make your life harder. So I'm just letting you know that it is possible to write binary search with the recursive method, but I would not recommend doing that. This will be it for recursion, and as always, let me know if there are any questions. If you don't understand something, I will be glad to help, and I'll see you in the next video.